Hello and happy Tuesday. I hope you guys had a good weekend. It was nice and long, so I hope you all got um, some time to spend with family or friends and do something fun and stay safe. So for this week, we are going to be looking at inequalities, which is very similar to equations. There's just one little symbol that's different, but the process to solving them is the same as it is with your equations. So for today, once you're done watching this video, I have attached screenshots of the 2 pages within the slideshow that has problems on it that I want you to solve. And then I have attached a picture of your notes. So I'm not going to go through the notes. I'm going to go through this slideshow instead. And you'll just copy the notes down on your own, or you can print my notes and put them in your notebook. Don't forget, for today, your attendance is actually going to be the bell ringer question, which is totally unrelated to your problems for today or the notes for today. Those are still things that are due today. It's your work, but for your attendance only, you'll solve the literal equation. And I'm going to try to add literal equations this week to keep giving you exposure to that and working on that. So what is an inequality? Well, an inequality is just like an equation, but instead of seeing an equal sign, you're going to see one of these signs. So you might see a less than sign, less than or equal to, greater than, or greater than or equal to. And the thing that you'll notice is the ones that are less than or equal to, or greater than or equal to, have half of an equal sign in them. So you see how the bottom part of that symbol has the equal sign? It only has one of them. That helps you remember, oh, this one is talking about greater than, but also equal to, because it has that line that goes with it. And another thing that I like to point out is that the symbols tell you which way to go. So if we were looking at this example, x is less than 5. It means that whatever x is, it's got to be a number less than 5. It can be anything. So it could be 2, it could be 1, it could be -8, it could be -400. Any number that's less than 5 on a number line could be your x value. And again, the reason I know that it's less than is because this symbol looks like an arrow pointing me to the left. And if we imagine a number line, over on the left-hand side is always our negative numbers, the middle is always 0, and the right-hand side is always our positive numbers. So this tells me which way to go, and that's less than. Another trick to help me remember that this symbol means less than is that it kind of looks like a sideways L, or someone who wrote an L really quick because they were in a hurry, and it kind of looks like an L to me. In this example, you see that doesn't look like an L. I can't even try to make that an L unless I totally twisted it around. But that's pointing to the right. Again, just follow my cursor. I'm using my cursor kind of as my pointer here as I share my desktop with you. So this means everything in this direction, everything to the right is what x could be, which again, if you think of a number line, any numbers on the right-hand side are positive numbers, and those are getting bigger and bigger all the way up to a million, infinity. So that means greater than, anything greater than -2. And it says right here, that means that whatever value x has, it must be greater than or equal to -2. Because again, you see that there's a line under that arrow. So x could be anything that's greater than -2. It can go or equal to -2. So it could be -2, -1, 0, 1, 2, 3, 4, 5, 6. All of those are numbers that are greater than -2. So when you're graphing these on our number line in just a second, this symbol, again, less than, because it is not equal to that number, you're going to leave an open circle at that number. And again, the arrow tells you which direction to go. We're going to go to the left. If it is greater than and it's not equal to and there's no line, your circle at that number will be open and you're going to move to the right, because again, look which way this arrow is pointing. It's pointing me to the right. And then if they have lines, no matter which way they're going, less than or greater than, they're closed circles. And then again, just depending on which way the arrow is facing, you either go left or you go right. And so some examples of that would be right here. So these 3 examples, these are great examples. X is less than 5. Again, that kind of looks like a sideways L to help you remember less than, but it's also pointing to the left. If it's pointing to the left, and we look at this number line, everything to the left of 0 is negative numbers. That's just getting smaller and smaller, right? So that's less than. And then the number that it gives us is 5. So you're going to put a circle at 5. Now, whether or not it is closed or open depends on if you have that symbol with a line underneath it. And since we don't have a line and this X value is not equal to 5, we cannot include 5. So this circle has to be open. We don't want to include 5. So imagine this circle doesn't really want to touch 5, but it has to start at 5. So it's a nice open circle that starts at 5 but does not include it. And then it goes all the way down forever and ever, and that's what this arrow shows, is that it continues in that direction. For the next one, our X value is everything greater than or to the right-hand side of -2. So you put your circle at -2, and they did, and you're going to be moving in the right-hand direction, and it's going to be an open circle because there's no equal then symbol here. But if you look at this very bottom one, you see how the symbol is less than or equal to, and the number they gave us is -8. So you start at -8 with your circle, and based on the symbol, you're going to do a closed circle instead of an open circle. And then because this is less than or pointing to the left, my arrows need to go to the left. So your line that you draw will go the same direction as your symbol. Whichever way your symbol is pointing, that's the way your line will go. Your dot will be on the number that you see. So as you see, 5, -2, -8, that's where all my circles are. And whether or not it's closed or open depends on if you have a line underneath or no line. And that's really it. So these problems right here, I screenshot for you and attached that. So you'll just plot these right here. Starting at -6, you'll do either an open circle or a closed circle, and you'll put a line either going to the right or the left. Same with 2 and same with 0. So you'll plot x is less than -6, x is greater than 2, and x is less than or equal to 0. Now you can either print this or draw your own number line and put your circle and your line above it. Either one. Now the next thing is solving inequalities, which is very similar to solving multi-step equations. So instead of an equal sign, you have your symbols that we just talked about. Greater than, less than, greater than or equal to, less than or equal to. So you still need to get your variable by itself. So if you're looking at this equation here, instead of it being x plus 5 equals 13, we just changed the symbol. But you still have to get this completely by itself. So anything on this side with the letter has got to go. I need plus 5 to come over to this side. So we know to move it, you just do the opposite. So I would subtract 5 because x plus 5 minus 5 gets rid of that plus 5, right? 5 minus 5 is 0. That gets rid of it. But if you do it to one side, you have to do it to the other. So you would move it over here, and you would get x is greater than or equal to a number, and so x would be by itself. And you'll do that with all 4 of these. It's exactly like your multi-step equations. Well, your 2-step equations, really, because there's just 2 steps to do. And this one, you have subtraction and multiplication over here with your x that you've got to get rid of. So you would add 14 and then divide away that 2. Remember, for undoing equations, we do PEMDAS, please excuse my dear Aunt Sally, backwards. We do it backwards, right? So we get rid of anything that's just a constant, that's just hanging out by itself, because that's addition or subtraction. Though it is last in PEMDAS, when we go backwards, it's first. It's the first thing we do. Then we would multiply or divide anything away. That's how we always make sure to go backwards with those, because we're undoing them. So your practice is to do these 4 problems as well. Solve for x, and then depending on which way your sign is facing, excuse me, and whatever your number is, you will draw that on a number line as well. And that is it for today's slides. So thank you for listening and paying attention. It's really quite easy, at least to start with inequalities. Eventually we'll get into how we graph them, but I want you to understand how we at least solve for them and how they work on a number line and what these symbols really mean. So at this time, now that you're done, go copy your notes down that I attached, and then work on your problems. Work on your 3 or 4, I can't remember how many of these I screenshot, and copy those down and solve for these and copy those down as well. And that's all that you have to do